An Old Stuart Double 10V in the workshop. This Old Stuart Double 10V steam engine is in need of some attention to make it run. Some parts are well made, but others are not. The question is, should I repair it? The introduction video is a bit confusing. The unpainted one is very well made and runs beautifully. This is the one that's going to be used in the Stuart steam plant. The one that's bothering me is the one in the background, the green one. That's the one with the really neat gaskets, oh yes, and a mammoth flywheel, and possibly the worst plumbing that I've ever seen, which is entirely wrong for a Stuart Double 10V. Not only is this pipework really horrible to look at, to make matters worse, it's soft soldered. On miniature steam engines of this type, which are running on steam at about 60 pounds per square inch, soft soldering is out of the question. The steam is hot enough at 60 pounds per square inch to melt the solder. Water boils at 100 degrees centigrade at atmospheric pressure, which wouldn't melt the solder, but steam at 60 pounds per square inch is very hot indeed. Slightly superheated steam at this temperature and pressure will melt the soft solder on the inlet piping. The exhaust side as shown here would possibly survive. The obvious thing that looks really wrong about this engine to me is the fact that it is fitted with a mammoth flywheel. Or is this one of the front wheels from a mammoth traction engine? I'm not sure, but it looks completely wrong on a Stuart Double 10. In this clip you can see another problem. Not only is it a mammoth type flywheel, it's been fitted to a very bent crankshaft. I will straighten this crankshaft in due course. This engine, along with a load of other bits and pieces, came from a customer in the USA, and in one of the plastic bags were the parts for this engine. This is the valve fork. I'll screw it onto the valve spindle. And it's looking better already. The next thing to fit is the eccentric sheave. This should just slide onto the crankshaft. But the eccentric sheave does not slide onto the crankshaft. Here I'm checking the diameter of the crankshaft and comparing it with the hole in the eccentric sheave, and they're both the same. The problem, as is very common with miniature steam engines, is ultraviolence. It looks to me like, in order to fit the mammoth flywheel to this engine, someone used a hammer on the opposite end. And with considerable force too, because the end of this crankshaft is peened over with the hammer blows. I started cleaning the end with a needle file, but it was taking ages. In the end, I held it against my 1-inch belt sander to clean off the corner. And here you can see that the eccentric sheave now fits on the crankshaft. I never really did understand the logic of Stuart eccentrics. On this Double 10 it uses a specially shaped small bolt which goes in the bottom of the eccentric strap to hold the strap in position in the groove on the eccentric sheave, like this. I much prefer locomotive style eccentrics where there is a flange at each end, which means no groove is required in the eccentric sheave, so there's more surface area and less wear. But alas, Mr. Stuart Turner did not design his models in this way. I fitted the strap to the sheave and gave it a good oiling. The next job is to remove this horrendous piping, just to have a look how it's put together. This engine is built quite wrongly in certain areas. Please wind back to the beginning to look at the other Double 10 and you will see the difference in the way the exhaust and inlet piping is. And as for this gasket material, whatever it is, I'm not sure. I'm removing it with a Stanley knife. If I do decide at some stage to rebuild this engine instead of just selling it on, I would make new gaskets. You can just see how wrong the piping is by looking at the casting on the left-hand side. Can you see the large holes that have been drilled? These have been threaded 6BA. OK, I'm being really picky. Once the flanges are bolted to the cylinder, you cannot see this. But that's not the point. It really bugs me when it's wrong. The inlet piping wasn't fitted to this engine, and I think I know why, because it doesn't fit, the holes don't line up. And the faces of the flanges were a bit of a mess. Here I'm cleaning them up using some emery cloth. This is my small Proxon blowtorch. I've bolted the flange to the cylinder at the flywheel end, and what I'm doing here is melting the soft solder to reposition the flange at the other end. After a while, by moving the end part, I got the holes to line up perfectly. In my opinion, the only place for this piping is in the scrap bin. The soldering is awful as well. But it will do for now. Here I'm oiling the engine thoroughly. Every part that moves gets a coating of oil. I also pumped some oil into the inlet pipe to lubricate the cylinders. I've set the valve timing roughly just by changing the position of the eccentric sheaves. One thing becomes obvious: it isn't self-starting, but once I give it a push, off it goes. It starts okay when I pulse the air, but then it will stop and not start at all. Here's a bit of slow motion just to show how wobbly the flywheel is. And by the sound of it, a lot of the air is blowing to exhaust. In this clip, I'm tweaking the timing a little bit to put it in a more tangible position. It was still reluctant to start, but when I gave it a push, off it went. Surprisingly, even in this state, and there is a tight spot as well, the engine is quite powerful. I'm going to remove the cylinder covers to have a look inside the valve chest and see what the valve's doing. But no one remembered to trim the gasket, so before I can get to the valve, I'm going to have to remove part of the gasket so I can see it. Luckily, my Stanley knife is quite sharp, which makes a change. Once I cut out the centre of the gasket, I could see the slide valve inside. My logic tells me that as the engine runs, the slide valve must be in approximately the right position. And now I can see the slide valve and where it is relative to the ports. I can adjust it so it's in a good position. When I set valve timing on a steam engine, I set the position of the largest lobe of the eccentric sheave at 90 degrees to the crank pin. Then I check the position of the slide valve to make sure that it's passing over the ports the same at each end of the stroke. And to do this, all you have to do is remove the bolt or pin that holds the eccentric rod in position on the valve fork, then rotate the valve spindle whilst it's still attached to the valve fork to change the position of the slide valve relative to where it is from the eccentric. There is a tight spot on this engine, and I know what it is. My experience tells me that the piston, when it's at the top of the stroke, is colliding with the cylinder cover. Colliding's a bit of a strong term really, it's just touching the cylinder cover. When I look very closely at this though, the piston is not colliding with the cylinder cover. It's a little bit too close, but it's just all the rubbish sealant that's fallen into the cylinder. Then as the piston goes up, it squashes it against the cylinder cover, and that's what's causing the tight spot. The good news is the cylinder bore looks to be in very good condition. There is a bit of a problem with the eccentric sheave, which is very common to Stuart models. The little tiny 5BA screw has broken, and also the hole in the eccentric sheave is stripped. Here, without dismantling the engine, I'm rethreading the sheave using a 6BA plug tap. With the eccentric sheave in situ, I can't get all the way through, so here is a special plug tap that I ground very flat, and in no time at all I was able to fit a 6BA grub screw. This is not good, the cylinders are not in line. It's an easy fix, but you have to dismantle the engine to do it. As I've got plenty of other jobs to be getting on with, I don't have time for this at the moment. The engine is now a little bit better. It's self-starting and it's quite powerful, and I've straightened the flywheel, so life is wonderful. The birds are singing and the sun has come out. It needs gaskets on the inlet and outlet pipes as well as other things. The flywheel was still very slightly wobbly, so I gave it a bit of my special treatment to straighten it up. And guess what? I'm not going to show you how I do it. I really daren't show you because there will be people out there who think they know how to do it and they'll just be smashing their engines to pieces. But I'll let you guess how I did it. The first clue is soft, and the second clue is hammer, and the third clue is knowing where to hit it. And these clues, in conjunction with a lifetime of experience of doing jobs like this, makes it possible to successfully straighten very bent crankshafts while they're still attached to the engine. That's it for now. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.